And the idea that you would take these machines and say, oh, one of the valuables is allow 11-year-olds, 12-year-olds to program them was, beyond revolutionary. It was simply insane.
Hi, I'm Dr. Jed Macosko from Academic Influence and Wake Forest University. And today, coming to us from MIT, we have Professor Hal Abelson, who is an expert in things like artificial intelligence. So, Professor Abelson, what have you and your students at MIT done to push forward the field of artificial intelligence?
Okay. So I've been working in artificial intelligence since I first got to MIT as a graduate student in, God help us, the early 1970s. And in those days, we were doing things that seem insanely primitive right now. Just question answering, symbol manipulation. I was involved in making some of the early AI languages that allowed people to work in, doing things like symbolic processing or reasoning or theorem proving. So those all seem like ancient things now. More recently, I've actually been turning towards education and making it possible for young people, even fourth and fifth graders, to create their own programs and run them on tablets and smartphones and do all sorts of exciting things. So that's where I've been working mostly right now, together with the general stuff of AI that kind of goes on. There's work in language understanding. There's work in image understanding, image recognition. All of that goes on, and it's been accelerating at a incredibly fast pace.
Well, I know as a father with 5 children all in school, they've all used the program that you and your colleagues developed. Tell us a little bit more about how you got the idea for it, how you came up with the name, all that good stuff.
Okay, well, the program that I run is called App Inventor. I did that when I was actually on sabbatical from MIT at Google. And that was, in 2007, which was the year that the iPhone first came out. And Google internally was building this thing called Android, which was mobile computing. One thing to understand when we think about computing evolution, there were no usable smartphones before the iPhone came out in 2007. So that's 13 years. But I bet when we think about it, it's hard to imagine that there was ever a time without that technology. It just shows how fast it diffuses and how quickly we get used to it. So I'd been in my own history. I came to MIT in 1969 as a graduate student, and I ran into a math faculty member there named Seymour Papert. If you've ever heard the phrase computational thinking, that's pretty much due to Papert. And Papert had this insanely revolutionary idea that programming computers could actually be intellectually valuable for kids. Right? So everybody says that now. But that was certainly not the case in 1970. Right? In 1970, computers cost a couple of $1 million each. And what computers were for is for the military and for industry to do data processing. And the idea that you would take these machines and say, oh, one of the valuables is allow 11-year-olds, 12-year-olds to program them was, beyond revolutionary. It was simply insane, not even revolutionary. And so we created this computer language called Logo, which was kind of the first language that was designed for kids. And again, the basic idea is that by programming, it was actually intellectually good to program.
And I used that program when I was in 5th grade. So you are the one who gave me Turtle Logo and all the fun things we did with it. And the funny thing, this is funny, but my son actually programmed in Logo this past summer at the Research Science Institute at MIT to model COVID spread. So Go figure.
I was actually involved in bringing the Research Science Institute to MIT. That was another fun thing. But anyway, so you've seen this language called Logo, and people use it. In any case, when I was in sabbatical at Google, again, that was the year that Google was first. It was right after Apple had introduced the iPhone, and Google was making Android, and it was this enormous mobile technology, and it was this first blossoming. Oh my God, there's this incredibly new technology that's around. And then coming from my background in Logo and also from my background in a program called Scratch at MIT, comes from the same roots, I said, gosh, why can't we take the same idea and make it so kids can use mobile technology? So again, just like in 1907, 8, 9, the whole world was explaining there's this wonderful thing called mobile computing that you can do. You can carry around this computing stuff in your pocket and do stuff. From my background in Logo, I said, wow, well, that holds for kids too. And so we created this language called App Inventor, which drew very much on Logo and on Scratch. And the basic vision was kids ought to be able to do exciting things with this technology.
Amazing. Well, we owe a lot to you, Professor Abelson. Thank you for thinking ahead about not just computers as big machines that can help scientists, but as things that can help us learn as children. So thank you for all those fun hours I spent in the computer lab as a fifth grader. And thank you for helping my children learn as well.
Well, incredibly, I'm glad that we can do things that has an impact, and it's still happening. Like I was saying a little while ago, the kinds of computer experiences that people and kids are going to have, in 5 years are things that just don't exist today. And appreciating that is it's just hard to wrap your mind around that. But it's true. I mean, I've got a friend, who works at Baidu, where people in Baidu are telling him, saying, 5 years from now, the major ways that people will interact with computers are speech and vision. And then if somebody said that a couple of years ago, and you say you're going to be talking to your computer as a way of getting it to do stuff, 5 years ago, you would have said, oh, well, I don't know this science fiction stuff. And now look at the number of people who have Alexa and Google Home.
I mean, I remember when I was at MIT as an undergraduate in the early 90s, my older friend at the fraternity was simply getting a computer to recognize yes, no, and cancel. Probably in your lab. But, that's how far we've come. It's just absolutely amazing.
Right. And then just say to yourself, I mean, it's like almost anything you can imagine, or at least the things that you find people at, weird places like MIT experimenting with, you can see that transition into something that's going to be available to everyone. And then you say, what are the possibilities of that? So it's a wonderful, wonderful field to be involved in.
It truly is. Thank you for all your work. And thank you to your students who you've mentored and who've gone on to do amazing things. So,
thank you very much.
And thank you for spending the time today. It was really good to get to know somebody who's been there from the very beginning.
Okay, it's been a pleasure.